Okay, enough talking about graphs. Today we're going to implement one. Welcome back, folks. Thanks for being here. It's finally here, the exciting continuation, I won't call it conclusion, of our discussion about graph data structures. There's definitely going to be, I'm sure we'll do more videos about graphs. If you have no idea what I'm talking about, check out my previous graph video. It sort of explains conceptually what we're talking about. I'll put a link down in the description because you might want to check that one out first. But today I thought we'd take some time to implement a graph together. This video will contain source code, and as you know, source code is available through Patreon along with some other stuff. And a huge thanks to all you wonderful people like Thomas Vogt, Ben Skodas, and Murugesh Sinikani who make this channel work. But now let's get back to graphs. So one of the things that's really interesting about graphs is because they're fairly flexible, they're a little more flexible than, say, trees or lists. There are a lot of different ways that you see people implement them. And people often want to know, is there a right way? Well, it depends. It depends on how you're going to use the graph, what operations you want to be fast, how much space you're willing to give to this graph, stuff like that. And so today I just wanted to start with one common way that people implement graphs, which is using an adjacency matrix. I talked about matrices and 2D arrays in a previous video, so check that out if you're not comfortable with that. I'm going to basically be assuming that you got a handle on that topic. But the idea with an adjacency matrix is pretty simple. Basically, say we have a graph that looks like this, that has, let's say it's got 5 nodes numbered 0 through 4, and the question is, how should we represent this in our program? Well, with an adjacency matrix, we can represent things just like this, where each row represents the node the edge is coming from, and each column represents the node where the edge is going to. So you can see an X in row 0, column 2, means that we have an edge that goes from 0 to 2. And of course, I've left blank the cells that represent the absence of an edge. So like there's nothing going from 0 to 3 in this case. Now in your program, of course, we're not going to use X's and blanks. We'd use something like a 1 or a 0 or a true or false, really however you want to represent that there is an edge or there isn't an edge. Now, one thing that we like about adjacency matrices like this is that they're fairly simple and straightforward, they're easy to visualize, and they're generally pretty fast, at least testing to see if there's an edge from, say, 3 to 2, I can just do something like this. And that's going to be fast. But keep in mind there are some downsides. The downsides are, well, whenever we have a sparse graph, that is a graph with not very many edges, but a lot of nodes, the matrix is going to get really big and there's a lot of space we could have used for storing other stuff. Now, also, if we're just looking at this example, if I want to go through and grab all of the edges leaving a particular node or vertex, I have to go through the entire row. And of course, as the matrix gets big again, and especially if it's sparse, then I'm going to have to test a lot of possible edges, most of which are not, in the case of a sparse matrix, going to be adjacent to the node. So that's going to be a lot of wasted effort. It's going to slow us down a bit. Also, what happens if I want to add a node to the graph? Well, it's definitely possible, but with an adjacency matrix like this, I'm going to have to resize the array, and that may involve some copying, which we'd also really like to avoid. But enough of the downsides, let's jump into the code and see how we actually implement this. Okay, so just to start off, I got a few starter files here. You're going to see some of the dots. These are just examples that I used in the last video. Check out that video, you'll get a sense for what those are. They're just dot files, and we're going to be using dot format later on. I have a make file, pretty standard here. Check out my make videos if it's not so straightforward for you. Also, I have main.c. Right now it's just an empty main function. We're going to get back to that in a minute. And we have basically an empty header file and an empty .c file. These are going to be for our graph module. Now, normally I would just call this graph, graph.h, graph.c, because in the interest of abstraction, the user probably doesn't really care how I implement my graph, but I intend eventually to have multiple implementations. I'm going to do a bunch of different videos on this, at least that's the plan for now. So for now, I'm going to name them specifically based on how I implement them. Okay, so let's start with this header file. Now this is going to be our interface to the graph. Right now, we just have if-def guards, okay? So if you haven't seen these, I have a video on them, check that out. And I also want to make my graph an opaque data structure. So let's go ahead and declare our graph like this. We're going to make it a struct, and we'll just call it something like my graph. We can call it whatever we want. I'll leave that up to you to change this if you want to. I would recommend that it's something descriptive, but it's totally up to your creativity. But the point here is that we don't want our user messing around with the details of our graph. We just want them to use it. And then let's look at how they're going to use it. So let's go down and let's make a few functions. Let's make one called create graph. And this one, I'm going to have it return a graph pointer. So it's going to allocate a graph. It's going to return a pointer. And then we're just going to pass in the number of nodes. that we want in our graph. Next, if we're creating and allocating, let's also make one called destroy graph. We could say free graph, but destroy is so much more dramatic. So I like that. And we'll just pass in, the graph that we want to actually destroy. Let's also make one that prints out a graph. So again, notice there's a pattern here. We're basically passing in pointers to the graph we created. I'm going to make this void as well because it's not going to return anything. It's just going to print stuff out. So then we probably also need to be able to add edges. So let's say, it's going to be we'll have a Boolean, we'll return Boolean because it may succeed or it may fail. And let's add edge. And this is the graph so we'll pass in a graph. That's the graph we're going to be making changes to. And then let's just pass in 2 ints. So we're going to have the from node and the to node. So this is basically saying that there's an edge going from a particular node to another node. And this is the graph that we want to add that edge to. And then we're going to do something very similar here. What we're going to do is we're going to make one that just says has edge. So that's just going to be a test to see, is that edge present or is it not? So one is adding an edge to the graph. One is testing the edge. Notice that it's complaining about bool. That's because if I'm going to use bool, I need to include standard bool.h. Okay, so that should take care of that. Okay, now of course at this point there are other functions that I could define here, other operations we could perform. We could talk about traversals and things like that. Let me know down in the comments if you have specific requests, things you'd like me to look at in a future video. But for now, this is gonna do. And at this point, what we need to do is let's just take these and let's go implement them over in our .c file. So we'll jump over to the .c file. Notice up here, it's basically empty. I just have a couple of header files that I think I'm gonna need. And I've got my include already for the header file. But we're just gonna add these and we need to come in here and actually implement them and we'll just stub them all out really quick, even though they initially won't do anything, but that's okay. Okay, now if we come up here, let's start with create graph. Okay, so create graph, it's pretty straightforward. We're basically just going to say, let's make a pointer G, to a graph, and then we're going to malloc space for it. So we can do size of graph, or the other thing we can do is we can do size of star G, and all that does is say, hey, whatever G points to, let's allocate something that size. Now, note that I forgot to actually just define what a graph is. So incomplete types, we can't actually get the size of, so let's also come in here and say struct, call it my graph, right? And what's gonna be actually in our graph, we're going to have int, number of nodes, let's add an S there. And then let's also we're going to use Booleans for our, is there edge or is there not an edge? So I'm going to make a double pointer and call this edges. So this is going to be my 2-dimensional array or my matrix. Again, check out my previous video if you're a little confused about how a 2-dimensional array is the same as a double pointer. Okay, so now jumping back down here, adding a semicolon there, jumping back down. Now we are able to allocate space for our graph, okay? Now let's just check really quick if G happens to be null, meaning that we had a problem with our allocator, we asked for too much memory, whatever, something like that. If that happens, we'll return null. Now I don't always do this in my videos because it tends to make things a little cluttered, but it's a good practice in general. When you're writing your code, it's good practice to check your allocations to make sure that you actually got the memory that you expected. Otherwise, you're likely to crash later on down the road because you're going to assume that you have a valid pointer and you don't. And then let's just set things up a little bit. Let's say our num nodes is equal to num nodes. Great. Okay, so now we've got basically the initial chunk of our graph. We have memory and we have a number of nodes set up. Now we need to actually create our matrix. So let's start out with, let's just allocate our matrix down here. And what I'm going to do, so first thing, let's just allocate our rows. So that's going to be, we're going to say our edges, the edges of G. Let's use calloc for this because that's going to handle some of our initialization for us. But we're going to say size of, a Boolean pointer because that is what we're dealing with. And let's say we have the number of nodes. That's how many of these Boolean pointers we want. Now, why is it a pointer? That's because each of these things that I'm allocating is actually going to be an array of Booleans. Okay, again, arrays, pointers, they're kind of the same thing in C. I do have a video on that if you need a little refresher. But let's come down here and now, again, if these edges that I just allocated, if that happens to be equal to null, then let's free G. So we're gonna just do some cleanup here and return null again. Okay, so again, just cleanup. Often you will not see this kind of cleanup code in example programs. I'm putting it in here because I just think it's a good practice. So now we have the rows, the row pointers all allocated. Now let's go through and we need a for loop. And let's go from 0 to num nodes. And we're going to here need to basically go through and create for each one of these. For each ith row, we're going to come in here and make another calloc call, which is going to give us the size of a Boolean and not size, the number of nodes. Okay, so this is the length and this is the size of each element, which they're just Booleans. Okay, so that should get us in good shape. Now, of course, let's check to see if, again, let's be consistent here. So if this is null, so if it failed again, then what we're going to do is we're going to clean up again. And this is going to, in this case, let's just, because we're starting to get a bunch of different things we're going to have to free. At this point, I'm going to just say destroy graph, and that's going to do with cleanup. This is going to actually save me a little bit of extra code. You'll see how this works in a minute. But yeah, so then we return null. Okay, so this is, again, we're just cleaning up in case one of our rows, we were not actually able to allocate it. And then once we're done with the for loop, then we simply can return G. Because if we get down to this point, we know that all of our allocations were successful. Now, you're also maybe going to say, hey, you didn't initialize this. One interesting thing about calloc is calloc will initialize everything to zeros for us. That's part of the calloc specification. So in this case, we didn't have to do any initialization. That's one reason why I used calloc here. Okay, so now because we're calling this destroy graph, we should actually implement that next. Okay, so let's come in here. Pretty straightforward. Pretty much all I'm going to do is say, let's check to see if for some reason our edges pointer is null. Well, then something went wrong. Who knows? But we're just going to return. And then, but if we have a valid pointer for edges, then what we're going to do is say for int I equals 0, I is less than the number of nodes, and I plus plus. And then so let's look at each row. If the ith row is not equal to null, then what I'm going to do is just free that. And the reason I'm checking each of these is that you notice I'm using destroy right here. If I was like, let's say I get halfway through allocating these different rows and I get a failure, I want to be able to go through and I want to be able to just clean up the ones that I've already allocated. So this check will help me with that. So I don't accidentally try to free something that I didn't allocate. And then down here, you can then just free G edges. Okay, so very important. You always want to make sure that you free the array of pointers before you free each of the rows in the two-dimensional array, because otherwise you could get seg faults, you could get just weird allocator problems that you probably don't want in your life. Okay, so now we have the ability to create and to destroy our graphs. Hopefully these all work. We'll test them in a minute. But let's go down, and the next one I want to do is just print out our graph. Okay, so print graph, it's going to take in a graph, and we're going to use the dot format here, and I'm dealing with directed graphs because this, we have the ability to say 2 goes to 3, but 3 doesn't go back to 2. So let's start off by just doing digraph and a new line. Now, if you're confused about this format that I'm using the dot format. I talked about it in the previous video. It's just a nice format for representing graphs that allow me to then generate automatically some nice pictures of my graph. I'll show you how we do that in just a minute, but that's the reason that I'm using this particular format. And then let's make another for loop, and we're gonna say int from equals 0. So we're gonna go through all the from nodes. You could, of course, do I and j here, but in this case, because there is actually some meaning here, I'll just stick with from and to. So we'll go up to num nodes and from plus plus. And then in here, we're going to do exactly the same thing, but we're going to go to, and 2, okay? Now, okay, so we're going to go through nested for loops because we're dealing with a two-dimensional array and I want to visit every cell in the two-dimensional array. And then in here, basically for each cell, we're just going to say if g.edges from and to. Okay, so we're basically saying if there's an edge that goes from the from node to the to node, then what are we going to do? Okay, well, we could just, one thing we could do is we could just print out %d, print out the number, and then we could print out the edge like this. So we could basically say something like this, where we're going, from one node to the next, And then we could have from and to here as our two integers that we're printing out. And we could just stick semicolon there. And now we basically have our edge being printed out. Okay, so this is looking okay. Now let's just come down. Let's actually add a new line after that. And then we're going to come down here after we're all done and let's close it off. Do our close curly brace and /n. And so this is going to print out our graph. Pretty simple. I could do things a little more fancily. The dot format allows me to, for example, like group multiple edges into a single edge. Like I could say 0 goes to 1, 4, and 5. And we could do that, but I'm just not going to bother right now. We should be okay here. And at this point, we've got some functions. So let's just take a look. Let's see what we can do really quick. Let's make sure that everything is working. Let's jump over into main. And here, let's just say graph pointer. We'll call it G1. And let's call create graph. And let's make it 5 nodes. Then let's print out the graph. There's probably not going to be much to be seen here. And let's destroy the graph G1. But yeah, so here I just want to make sure things are basically working. And here we can compile. And we're getting some warnings. It's not liking a few things. Okay, so it's not liking the fact that I said print instead of printf. Good. And then we're also seeing that there's some non-void pointer functions that are returning nothing. So let's, for now, just to quiet these, let's return false. And return false. We will come back to you later. Okay, so now it compiles just fine. And we can run it, and we see we get an empty digraph, which is outstanding. Now let's go in and actually try to make this do something a little more useful by actually adding an edge. Okay, so really it's simple adding an edge. We can just say if g edges from node to node. Now what I'm going to do here is I'm actually just checking. And actually, let me change this up a little bit. Sorry to think on the fly, but I just want to do this slightly differently. What I'm going to do, I'm going to implement both of these, but we're going to say if has edge g from node to node. Okay, so if it already has an edge, then I'm going to return false. Otherwise, what I'm going to do is say, let's add the edge. So we'll say edges from node to node equals true. Okay, and then we are going to return true. Now notice I'm creating an add. Right now I'm not creating a remove. Removal is basically exactly the same as add, except that instead of setting something to true, you're going to set a cell to false. So in case you want to add that function, be my guest. And then let's also jump down and we need to, now that we're using has edge, we sure better implement it. And so let's basically just say here, return edges from node to node. And just as a sanity check, I'm going to come in here and add some assertions. So let's just in case there's any bugs, I don't think we've made any mistakes, but we'll put some sanity checks in here. Say, let's just, because we're assuming that G is a valid pointer, I'm going to assume that the from node is less than the number of nodes. I'm going to assert that the to node is also less than the number of nodes. Okay, so these are just going to basically keep things sane. If any of these things are not true, then it's definitely a bug and we want to flag it. And so let's actually add the same assertions up here. If you haven't seen asserts before, it's a really useful way to catch bugs early. And so now we should have, I guess, working implementations of all of our functions. Let's come down and just compile it really quick. It looks like it at least compiles. Let's come back to main. Okay, so now we want to actually put something in our graph. So let's come back and let's add some edges here. So what we're going to do is let's just say add edge, G1, and let's say 0 to 1. While we're at it, let's add. We're going to add a bunch of edges. Let's do 0 to 1, 0 to 2, 0 to 0. Basically add one edge pointing to itself, just in case you want to see what that looks like. And then we'll have 1 go to 2, have 1 also go to 3, 3 goes to 4, and we'll say 4 goes to 1 and 4 goes to 0. Okay. So this just gives us I don't know what this is going to look like. It gives us some interesting edges to play with. And then we can come in here and compile it. And now let's just see if it runs. Great. Okay, so this is basically looking the way I expected it to. We can see all of our edges in here. And because it's in dot format, what I can do, you may have noticed that in my makefile, I have this viz target right here. This just allows me to come down here and say make viz, and that's going to generate a viz.pdf. and we can open that up and just see what it's going to look like. And so you can see I've got my nice picture of my graph that I just created. That was the reason for the format. And so that's nice if you prefer pretty pictures to terminal text. Some people do, some people don't. But the point is now you have a working graph implementation that's using an adjacency matrix. I hope that's useful, helps you see one way that you can implement graphs. I'm definitely planning on touching on graphs and other implementations in a future video, maybe more than one. Make sure to let me know if there's things that you'd like to see. Be sure to subscribe to the channel so you don't miss next week's coding adventure. And until next Tuesday, I'll see you later.